Radioactive decay. Radioactive decay is the spontaneous and random disintegration of a heavy, unstable nucleus into two or more stable products with lower total mass, thus the emission of radiation such as alpha particle, beta particle, and gamma rays. The nature of radioactive decay means that it is not affected by external conditions such as pressure, temperature, magnetic field, or electric field, or chemical reaction. Random. Radioactive decay means that it is not possible to predict which nuclei will decay or when they will decay. It is possible to predict fraction of nuclei decay per unit time. There are three types of radioactive decay: alpha decay, beta decay, and gamma emission. Alpha decay. In alpha decay, a helium nucleus is emitted. The nucleon number of the decaying atom decreases by 4, while the proton number decreases by 2. As alpha particles are large and heavy, they cannot travel far. Their length in air is only a few centimeters. Alpha particles are also not very penetrating. They can be stopped by a piece of paper which is 0.1 mm thick.
Beta decay. In beta decay, an electron beta particle is released. The neutron number of the decaying atom remains the same, but the proton number increases by 1. This is because a neutron has transformed into a proton and an electron. The new proton remains in the nucleus, so the proton number increases by 1. The new electron is expelled from the positively charged nucleus and leaves the atom. Beta particles are lighter than alpha particles. They can travel up to a few meters in air and can pass blood vapor. However, they can be stopped by a 5 mm thick piece of aluminum. Gamma decay. Gamma rays are electromagnetic waves which are released as excess energy when an unstable atom goes through alpha or beta decay. They have no mass or electrical charge and do not cause any change in the neutron or proton number of the decaying atom. Gamma rays are highly penetrative. They can easily pass through paper, wood, and human body. They can only be stopped by thick lead and concrete with a thickness of a few meters. As a result, gamma rays are dangerous. This table summarizes the characteristics of alpha particles, beta particles, and gamma rays.
They each spontaneously randomly emit a particle and transform into a different nuclei. There is absolutely no way to predict whether any given nucleus in a radioactive sample will be among the small number of nuclei that decay during any given second, or have the same chance. Although we cannot predict which nuclei in a sample will decay, the decay process is probabilistic in nature and can be described with statistical calculation for a radioactive substance. If n is the number of undecayed radioactive nuclei present at some instant, where lambda called the decay constant is the probability of decay per nucleus per second.
Where the constant n0 represents the number of undecayed radioactive nuclei. The decay rate, which is the number of decay per minute, where r0 equal to lambda n0 is the decay rate at time equal to 0. The half-life of radioactive substance is the time interval during which half of a given number of radioactive nuclei decay. A frequently used unit of activity is the Curie. The SI unit of activity is the becquerel.
Fission. Nuclear fission is the splitting of large atomic nucleus into smaller nuclei. Nuclear fission is a process where the nucleus of an atom is split into two or more smaller nuclei, known as fission products. The fission of heavy elements is an exothermic reaction, and huge amounts of energy are released in the process. Nuclear fission occurs with heavier elements, where the electromagnetic force pushing the nucleus apart dominates the strong nuclear force holding it together. In order to initiate more fission reactions, an atom is bombarded by neutrons to produce an unstable isotopes, which undergoes fission. When neutrons are released during the fission process, they can initiate a chain reaction of continuous fission with substance itself.
Fusion. Nuclear fission is a reaction through which two or more light nuclei collide to form a heavier nucleus. The nuclear fission process occurs in elements that have a low atomic number, such as hydrogen. How does nuclear fission take place? When deuterium and tritium fuse together, their components are recombined to form a helium atom and a fast neutron. As the two heavy isotopes are recombined into a helium atom and a neutron, the leftover extra mass is transformed into kinetic energy. The universe is full of instances of nuclear fission reactions. Every star uses it to produce energy. It produces greater energy than the fission reaction, and it requires a lot of heat and pressure for the process to happen.